all you peeps. I'm sitting here at school. It's awful quiet and lonely. Miss you all. But I just wanted to show you this this demo that we usually do when we're talking about the water cycling, especially water cycling through the oceans. And so here's the setup. We have just water in either side. And what I'm going to do is make some of the water cold and some of the water hot. And this weird H-shaped thing is also full of water, which currently is all the same temperature. So, adding ice to one side. I'm spilling ice. Okay. And then this is water that I put in the microwave. It's not super hot, but it's warm. Kind of like bath water. Now, how does this simulate the oceans? Where would the warm bath water stuff be? At the equator. And where would the cold ice water be? Melting off of glaciers or off of ice caps. So this would be at northern or southern latitudes. Okay, so what do we know about anything that's warm and anything that's cold? When things get warmed up, the molecules move faster and bounce off of each other. So the water on this side is going to be less dense, and the water on this side is going to be becoming more dense as it cools off. So we can't see any movement right now because it's all the same color. So what I'm going to do is add blue to the side with that's cold. Just a few drops of food coloring. And I'm going to add red to the side that's warm. And let's see if we can see what happens. I've just got this paper behind so you can notice any differences. Get a plain sheet of white paper. Okay, so I'm starting to see something happening. Notice here on the bottom that the blue water is starting to cross this direction. And I can just barely start to see the red water is starting to cross in the top tube. And the blue crossing on the bottom tube. So what does that mean? Well, it means that the cold water is falling down. If we're picturing it through the ocean, it's falling down through the ocean and creating deep currents. And then the warmer water from the equator is rising and would be moving along the surface. Okay, so just 2 or 3 minutes have passed by, and you can see the top tube is completely red, and the bottom tube is completely blue. And over here, the blue water is like falling downward into the bottom. Let's see, let me change this around a little bit. Can you see how the bottom of this one is, the bottom of the red column is turning blue? And then the top of the blue column is turning red. So this is the type of circulation that would occur in the ocean. This is how heat is transferred, because the water, when it heats up, becomes less dense and flows on top of the ocean. The water, when it becomes colder, becomes more dense and sinks to the deep ocean and becomes a deep ocean cold current. Okay, hope that helps with the transfer of energy through the oceans and setting up these slow density currents. Also, salt water is more dense than fresh water. So this would occur, salt water would sink, fresh water, when it arrives from the rivers, would sit on top of the ocean. And in the middle of the ocean, where evaporation occurs and concentrates the salt, the water becomes more dense and then sinks there because of its high salinity. Okay, hope you guys are doing great at home.